Hey guys, last time we talked about 3.8, we talked about differentials and marginal analysis. In there, we have to compare the two quantities, delta y and dy, and we have two formulas for them, right? Delta y, this one is the change in y, right? So this one I'm going to put like change in y, and this one is the real value, like the real life value. It equals to f of x plus delta x minus f of x. And the other one, the other quantity that we usually use to compare is dy. This one, it equals to the derivative of y times dx. Okay, or usually if you want, you can also use like the formula or like the symbol of f of x dx. Doesn't really matter. Okay, and this one is, it represents a differential, and it, as you can tell, it has a d in front, right? So it means differential in terms of y, and then this one is a fake value. Okay, and then the conclusion that we made from the last worksheet is that we're always gonna have like delta y equals to dy approximately. Okay, and now today let's talk about the derivatives of exponential functions. Okay, so this table in here is a review of all the old formulas that we had. We have constant rule, we have power rule, constant rule, multiple rule, and then the sum rule, the difference rule, product rule, quotient rule, and also chain rule, right? This table in here might look a little bit different because we have everything in terms of x. That's why we have like the dx coming along like on the bottoms. Pretty much like all the formulas in here. But again, this one in here is just like, it tells you that we taking the derivative in terms of x. Okay, but we're not actually dividing everything by x. We're not gonna divide anything by the dx. Okay, so that's just like I said, it's like the symbol. Okay. So before we talk about more derivatives of, exponential function, let's review a little bit about exponential function. In section 4.2, a long time ago, it was stated that the most convenient base for exponential function is the irrational number e, right? And then if you remember about e, we do have a definition for e, right? Like e is the limit of some function, okay? That doesn't really matter, but just like a reminder. Okay, so the convenience of this base stems primarily from the fact that the function f of x equal to e to the x power is its own derivative. Okay, so this one is literally what it means, and I'm gonna summarize it in the table. Like I'm gonna put it in a box in the next page. Okay. However, this is not true of other exponential functions of the form y equals a to the x. Okay, so say if you're gonna get something like y equals, I don't know, like 2 to the x power in here, the derivative of y is not 2 to the x. Okay, this one is glitch, so let me put it right here. Okay, but if you were to have like y equal to e to the x, then the derivative of this function is indeed the same thing. Okay, so e, if you have a base e, the derivative is the same. If the base in here is not e, the derivative is not the same. Okay, so now let's talk about what I just said, the derivatives of exponential functions. Okay, so if there's something you have to remember this one in here. The derivative of e is itself, okay? And if you were to have like some extra thing on the exponent, like a u function in here, make sure you multiply it by the chain rule, okay? And I'm gonna demonstrate it by the following example. Okay, so let's talk about the first note in here. Note that the slope of the tangent line to the graph of f equals to e to the x at any point, x and then e to the x is equals to the y coordinate of the point. Okay, so what does it mean, right? Like if you were to plug in x in here, well, obviously you're gonna get e to the x, right? Because, well, it's just what it is. So this one in here is actually the y part. Okay, so it equals to the y coordinate. This is what it means. Okay, so say, what does it mean, right? So say if you're gonna have like a function like e to the x, we all know it's gonna look like this ish, y equals to e to the x. Okay, where this is like 0, 1, if you want to like be more specific about it. We do have the graphs of e to the x in the previous sections. I don't really remember on top of my head what section it is, but I'm pretty sure it's about like chapter 4 if you guys want to check it out. Okay, so it means that, well, say if I'm gonna plug in x equal to, I don't know, like 2 in here, then it's y coordinate. it should be y equals to e to the second power, right? So then if I put it together as a point, I'm gonna get 2 comma e squared, right? In general, for whatever x it is, it's gonna be e to the x, right? So then this is what it means by this. Like x and e to the x is the point in there, okay? Okay, that's like for explanation, but then if you don't get it, that's fine. Let's talk about the real work in here after I delete this thing. Okay, so what do we have in here? We have to find the second derivative. Okay, so we have to find the first derivative of f, and then after that we have to simplify all the work in there, and then we take the second derivative of that. Okay, so then f of x, f prime of x in here, it equals to what? Well, right with that, I know for a fact that this one is a quotient, so I'm going to go ahead and apply the quotient rule in here, okay? So I have my f equals to e to the negative x, and then my g equals to x. And let me get this out the way. Okay, so then I'm going to get f prime equals to, well, first of all, because I know for a fact that the derivative of e is itself, so I'm going to write itself, right? Just because of this formula, right? Like, derivative of e to something is the same thing as it is. So this one, copy and paste. That's the same thing as for derivative. But here's the thing. We do have the chain rule, right? So how do you see the chain rule? Well, you have to multiply it by whatever the derivative of the exponent is. And then the derivative of the exponent in here is negative 1. Okay? And if you want, I can slow it down a little bit in here. So say we're going to have the inside and outside thing. Okay, let me put this one in like another color. Just so we like clear which one we talk about. Okay, so this one is like the inside and this one is like the outside, right? So inside we're gonna get like negative x equals to u, and on the outside we have e to the u. Okay, and all of this is for f. Okay, so then the derivative of negative x in here, it equals to negative 1, and then the derivative of e to the u, it equals to e to the u. Okay, so now because we don't have anything to do with u, so we have to put it back in terms of x. So then we have to multiply negative 1 with e to the negative x. This is where the e to the x and the negative 1 coming from. Okay, so let me get rid of this, and just trust me, like when you get a hang of the chain rule, it's actually not too bad. Okay, but at the beginning it can be a little bit confusing because we always forget to take the chain rule, and then it affects a lot. Like you're gonna get the whole problem wrong. So make sure you remember how to do the chain rule. Okay, and then g prime in here, we all know that equals to 1. Hopefully. Okay, and now the work, let me put it in green. So then f prime in here of x equals to f prime times g. So this cross in here, that means we're gonna get negative x e to the negative x minus, as for the part of the quotient rule, f times g prime, which is 1 times e to the negative x, which is e to the negative x. Okay, so then that is what it is for the first derivative, right? And then wait, I forgot the bottom. It's like everything over g prime, which is x squared, right? So this is it, and then now let's talk about the second derivative. Let me put in blue. Okay, how can we get the second derivative, right? Well, we're still gonna have the top and bottom like things in here, so that means quotient rule, right? So let me get rid of this, and then let me just put like so in here my new f would be negative x, and then e to the negative x minus e to the negative x, and then my g, let me put it in brown, equals to the bottom, which is x squared. Okay, so for the top part, it's going to be harder. F prime in here equals to the derivative of this minus the derivative of that, right? Okay, this is like the hard part, right? So this term in here, the derivative of it, it has to do with product rule. How do I know that? Because I'm seeing negative x times e to the negative x, right? So on top of this, okay, let me put in, I don't know, orange. We're gonna have like another f equals to negative x, and then g equals to e to the negative x. Okay, and in here I have f prime equals to negative 1, and then g prime equals to negative e to the negative x. Okay, The negative is coming from the chain rule, like the derivative of the inside, and then the e to the negative x coming from the outside. Okay, if you want to produce like the same table as I just drew from before. Okay, and because I told you that this is the product rule, so we're gonna multiply them and then we add them in between. Okay, so it goes like f prime g, which is negative e to the negative x, plus f g prime, which is x e to the negative x. Okay, so this whole thing in here is the derivative of just this part. Okay, I can do a better circle. Okay, so let me just copy and paste this in here. If I can. You know what? Let me just rewrite in here. How about that? Okay, so e to negative e to the negative x, and then plus x e to the negative x. Okay, but then on top of that, I still haven't write out like the derivative of the second term, right? So let me just move this thing a little bit to the right. Like that, so then we have more space for it. Let me get rid of this. Okay, so then let me put it in, I'm running out colors, purple. So then the derivative of this in here is again by chain rule, so we're gonna have minus negative e to the negative x. Okay, and then for g is in brown, so then g prime in here is equal to 2x. Okay, and let me get rid of all this work in here for the product rule. Okay, so how can we simplify this f prime, right? This in here, well, if we break out the parentheses, the two minuses become a plus, right? And this plus e to the negative x will cancel with the negative e to the negative x. So eventually f prime equals to x e to the negative x. Okay, and then what do we do after this is that we're gonna get the second derivative. So let me put it in, what's another color that I haven't used? I don't even know, this greenish. So the second derivative in here equals to f prime g. So I'm gonna multiply the x squared with the x e to the negative x, so I'm gonna get x cubed times e to the negative x, and then because this is the quotient rule, I go minus, and then I'm gonna go ahead and multiply each of the terms in here with 2x. Okay, so then it goes like negative 2x squared e to the negative x for the first term, and then minus 2x e to the negative x for the second term. Okay, after that I'm gonna distribute the negatives into the parentheses, so I will have x cubed e to the negative x for rewriting, and then plus 2x squared e to the negative x plus 2x e to the negative x. Okay, and everything is over g squared, and my g squared in here is x squared, so that will be x to the fourth power. Okay, and lastly in here, it looks like I can simplify some more of them. So let me go ahead and factor out like an x and also an e to the negative x. So it's gonna look like x and then e to the negative x. And then on the first term, I end up having x squared on the inside. Second term, I have 2x, and then we have a 1 for the last term. Or should I say a 2? And on the bottom, I'm still gonna get x fourth. Okay, so what we're gonna do is that we're gonna cancel the x in here with the power, and then at the same time we're gonna rewrite the e to the negative x because it has a negative power, so it belongs to the bottom. Okay, and then the new power for the x forward in here is canceled at one of the x's, so it's just half like x3 or like x cubed. Okay, so then the new top in here will be x squared plus 2x plus 2, and this is the final answer for the second derivative. Okay, so now as for your turn, let me take all this away. Okay, let's have you guys do this one. Okay, it's gonna be easier than mine. Okay, but just give it a try and let me know if it doesn't make sense or if you guys need help on that one. Okay, and then next up we have objective 2, applications. In chapter 3, we learned how to use derivatives to analyze the graphs of functions. The next example applies those techniques to a function composed by exponential functions. So our own concept in here that we have to remember that if we have the function where e to the a equals to e to the b, that implies that a equals to b, right? Like if you think about it, we just L on both sides, so it's gonna look like, okay, let me put it in green.